Hi, everyone. Um, More Shapeless this morning. I'm sorry for that. um, yes, it works. My name is George. Follow is me on Twitter and GitHub, and if you want to make my phone buzz in my pocket, make me uncomfortable by that, feel free. There are slides on GitHub, and also the code that I'm going to be showing is also there. Feel free to check it out. It's like 50 lines of shapeless code, and I'm going to try and walk through this today. I work for SoundCloud. There are some corporate slides that I'm going to skip because no one cares about that and we don't have much time. If you want to talk about this, feel free to catch me in the hall after the talk. So the thing is that I can probably safely say that we've switched to Scala these days. We used to be a Ruby shop. I think no one's going to hold a grudge at me if I say that we're a Scala shop right now. And I would attribute the fact that we've switched to Scala to one of our internal frameworks, which is, we call it JVM Kit, and it's basically a thing that we've built on top of Finagle that like encodes all the assumptions about our infrastructure. And so if a new or an old person wants to create a new service, they would just like spawn it with JVM Kit and like have access to everything, not have to think about like where to send metrics, where to send exceptions, how to access rollout flags, things like that. Everything is done for them. We only have that for Scala, which is probably why Scala has kind of won. And so the motivation for this talk is that I usually talk about, well, type-level things, type-level programming fascinates me a lot. And I usually give these talks with kind of weird examples, like, for example, solving Hanoi towers in type-level, which are all fun and good, but people usually, like, the first question after the talk is usually like, so how do you, what do you like seriously do this in your code at work? Do you like solve Hanoi towers? Is that why SoundCloud is not profitable? So I figured that maybe it's better to like show something more real world. When I first joined the company, this was how we produced JSON. We were using json, and you would like throw whatever at it, and it would like spit out JSON. Obviously, at some point, like it was written by people with Ruby background, so you cannot really blame them. This is like how they're used to treat types, like not have them. But so this ended up producing several bugs. I remember one when someone would just like throw a future inside, and that would like take out all the fields from the future and like generate this huge thing. Or even worse, we kind of used play.json to parse the payload that comes from outside. And so someone would like parse the payload, take a JS value, do some changes on it, maybe like change a field or something, and then throw it back there. And because Jackson knows nothing about JSON value from play.json, it would like again generate, instead of like taking whatever is like toString of that or something, it would just generate like for every value like a thing, huge, horrible piece of code. So the first thing that I felt was very important for me to do was add an alternative method that uses a type class to write a JSON. And the reason this uses play.json is, as I said, historically it was there. And you know, like it's not very easy to change a JSON library in a company with like 200 people, 400 microservices. But by now, this is not called type.json. This is called JSON, and we got rid of Jackson. But anyway, people kind of started liking this approach. First everyone was like a little bit hostile. It's like I cannot throw anything anymore and like get JSON. This is not amazing. But then they would like discover this thing where there is a macro in play.json that can generate an instance of writes for everything that is a case class. And people were more or less content. They were like, oh, OK, so I need to like write one line of code, and it's going to work the same way as it would. And then if I mess something up, and there's a future, the compiler will tell me. So win-win, kind of. But then at some point, this macro is not robust enough, right? So for example, it relies on the fact that case classes have apply and unapply pair, and like if you have more than 22 fields, Scala doesn't generate unapply anymore, and so this thing doesn't work. So like you get these kinds of things, which yeah. So the compiler basically says that there is no unapply. Which sounds like a toy example, but I mean, in legacy systems, I can trust me. There are things like that. Like, there you go. So like, yeah, this is the representation of the track that you're getting from SoundCloud, and this is what you have to write with your hands, and this is even a bigger one. There you go. And you're like, seriously, computer, aren't you supposed to be like good at these things, like generating code for me? Why am I writing this whole thing? And back here. So what we did is basically we tried to emulate, try to write a thing that would derive instances for case classes with more parameters than 22, which was our initial motivation. But we ended up doing a little bit more, like just because Shapeless can do so much more. And we tried to basically emulate the same behavior. So like this JSON that you see there, it's not play.json JSON, it's a JSON in one of our packages. And so the code that you've seen there, it was rewritten. Yeah, so like basically, this is the serializer instead of that huge thing. Back. Yeah, and this is how it works for the same class. Before the play.json one couldn't derive a codec, and our JSON, well, could. So how does this work exactly? So first attempt that I immediately thought of, like how would I do that? I was like, okay, so there's a macro somewhere in play.json that I can go and like probably tweak. Like how hard is it to, instead of finding an apply and an apply method and like taking out the parameters and like making sure they're the same and like generating these things, how hard is it to just like check there is a case class, take out all the fields with all their names and like put them in a JSON? Should be easy, right? Nope. So here's a macro in play.json repository. I reloaded it yesterday. This is all one method. Still scrolling. This is 700 lines of code of macro code. I'm still scrolling, by the way. It is, I mean, it's very well documented, but it does so many things. It does crazy amounts of things. It tries to figure out what kind of codec you want in the same method. So there are no like. You would expect there to be a macro for reads, a macro for writes, and a macro for a combination of those, somehow combining those two macros. No, there's one method that kind of figures out what you kind of want. And I think kind of does implicit resolution for you instead of using Scala compiler. So it's pretty scary. To be fair, what we're going to end up using also has a macro. It's defined in the Shapeless repository. It's also a beast, but it's like 100 lines of code beast instead of 700 lines of code beast. I did not have to change anything there, so that's a win, right? So before we get into the code, we basically need to quickly understand two mandatory building blocks and one optional. We need to understand what HLists are. We need to understand what generic is. I'm gonna tell a lot of like tiny lies to simplify the whole thing, but the whole gist is more or less the same. And then we probably need to understand what Coproducts is, but that doesn't really impact our original motivation of having a thing that produces codecs for case classes of 23 fields. So let's start with HLists. HLists are basically like lists, but they retain types of every element in the list, and they retain them in a type signature. So this is an HList which stores two values, which is a 1, a long, and a string. And if you look at the type signature, that's exactly what it represents. The type signature is says that there's a long and string and the end of a list. And then when you try to access those elements, you would get specific types. When you try to access the first element, you get a long, and when you try to access the second element, you get a string. And when you try to access the third one, you get a compilation error. It's pretty straightforward. This is like the most important building block of Shapeless, I would say. And then generic. Generic is something that is built on top of the macro that I just showed you, the 100 lines of code macro. Generic basically can look at your case classes and generate, like take out the fields and generate a representation for them. So if we define a case class that is a track, it has an ID and it has some payload. We're going to make it a string for it to be simple. And then generic.apply for that track would generate something that says macro, something that has this representation. And representation corresponds to the order of the fields in the original case class. So like an ID, which is long, and a string, which is a payload. And so why is this useful? This is useful because we can basically jump from one to another. We can take our track up there and turn it into an HList, which we call representation. And then it behaves the same way as the HList that I showed you before. And then, and then you can take the HList and like turn it back into a track. So that's this is pretty straightforward, right? We have a case class with two fields. We basically take out those two fields with their types, and we turn them into an HList. The code that I'm going to show you, please ignore it. There's a lot of code. Please ignore it. This basically, what we do is we define a type class for an HList, and then Shapeless figures out how to turn that type class into a type class for an instance that corresponds to that HList, right? So as I said, ignore this code. First thing we do, we define what happens when we get an HNil. An HNil is an empty HList. So when we get an HNil, we just produce an empty JSON object, which is like curly brackets for convenience. When we get, second thing we need to define is we need to define a case when we have a non-empty HList. We have a head and a tail. And the head is some kind of value, and the tail is the continuation of the HList. It might be an HNil, which is, if we get into an HNil, it's going to go to the first case. Or it can be more values. And so what we require is that the head over there has a rights. So the compiler will first find the codec for the head. If it can serialize it, it's going to try and serialize the tail. And so what we do is that we basically serialize the head, serialize the tail. We look at the head and tail. If the head is null, which is the case where, like, for example, we have an option, and we don't want to, if the thing is a none, we don't want to put it in the JSON. We just want to emit the whole field. We're going to just, like, use the tail. Otherwise, we're going to annotate the head with the name and append the tail to it, append it to the tail. Right, so basically what we're doing is that once we got to the end of the HList, we're going to produce an empty JSON that will just be appended to whatever JSON we've produced so far. And like on every step, we're going to produce a JSON for the value and try to produce JSON for the rest. And then the last building block is that we need to explain to Shapeless. So we've built this instance for an HList of values. And now it needs to understand how to go from that instance instance for an HList to an instance for the case class, which is this. We basically transform our value to an HList and write it. That's basically it. And the whole code is in the repository. And so if you look at the whole code, I'm going to go back to that code because it's not as scary anymore, probably, maybe. So there are three things that I didn't talk about. The first one is, oh, it's actually not on this slide. Let me go back here and probably open the code. Scala conference. There we go. There we go. So three important things. This with default is there because I'm lazy and I don't want to write all the serializers for simple types like int, double, option, list of things. And so this will just pick them up from wherever they're defined in play.json. This is there because our serializer will be very eager to serialize units to curly braces, and we don't want that to happen. We want people to actually not serialize units because it doesn't make sense. They probably made some coding mistake if they're trying to serialize a unit. And so what we do, we basically create two writes of the same type for unit that would trip Scala compiler into saying that there are two, and I don't know which one to choose. And since 2.12.1, there's an annotation for you when you use this trick to like say what's happening. You're not supposed to serialize units. And the third thing is, so I lied a little bit. There's these two cases for empty HList and for full HList, but there's also coproducts, and I'm going to talk about them a little bit. With defaults, this thing, and yeah, this is the error that you're getting when you try to serialize a unit or something with a unit. And a coproduct. So coproducts are a different data type. They're kind of another building block for everything that happens with Shapeless. So where HList basically represents your case class, your number of values, and associated types, Coproduct would represent your sealed trait hierarchies. So where HList is this value and that value, Coproducts are either this or that or this. So it's basically an either, but with more than 2 values. Here's an example. There are 2 things that can be played on the platform, a track and an album. And so both of them are playable, but they have different representations. So track has an ID and the payload, and album is basically a list of tracks. So if you look at the representation that generic has created for us over there, and I'm lying again a little bit, but this would not have fit the slide if I were to expand album and track into HLists. But this is basically saying that the representation is that there's either an album or a track. And CNIL is basically kind of an HNIL, but without representation, just to terminate the whole thing. There needs to be something to terminate. And so, obviously, that's another thing that play.json cannot do. It doesn't know anything about sealed trait structures, and in that 700 lines of microcode, I have no idea where to put that to be able to, and how many more 100 lines of code I would generate. So over there, it's just I don't know. Our version, well, yeah, works thanks to Shapeless, and there we go. It basically generates the JSON for it. I know that I basically jumped a lot of hoops, and I'm not sure if I was clear in a lot of these things. But there's a book by Dave here. It's very to the point, very straightforward. I definitely encourage you to read it. There's an alternative implementation of things for play.json by Christopher. He was actually one of the brave people to sit down and write a lot of macros around that 700 line of code monster to produce things for sealed traits and case classes with more than 22 elements. Yeah, that's all I've got.